Anytime that we're talking about polynomial functions, it's important to consider the end behavior. That means what happens to this function as it approaches negative infinity or positive infinity. And in order to determine end behavior, we look at the degree of the function, and it's not so much important what the number is, but we need to know if it's even or odd. So let's say we have a function that has, and we have 4 cases here. We can have an even degree. There's 2 of those. We can have an odd degree or an odd degree. So there's 2 of each, because depending on what the leading coefficient is of each polynomial, that will change its behavior. So it could be an even degree with a positive leading coefficient, or it could have a negative leading coefficient. It could be an odd degree with a positive leading coefficient, or with a negative leading coefficient. Now, what I want to show you is that there are similar functions that we already know from our library of functions. So if it is even with a positive leading coefficient, that is similar to our function y equals x squared. And we know that that looks like a U and opens up. And you've seen me use arrow notation when we're talking about in behavior. I'll go both ends up. Another way to describe this in behavior that you need to know, especially those of you that will be moving on to calculus or the 1 semester calculus, we need to be able to describe this based on the 2 ends. So if we look on the left, well, the left side rises. So we say it rises left. And on the right side, it also rises. So it rises right. And as you look at the function itself, the left side rises and the right side rises. So that's how we describe it. Rises left, rises right. If it's negative, then that looks like our y equals negative x squared. And we know that's going to be a parabola that opens down. So I would say both ends down, both tails down. And as we look at the left side of the graph, well, it falls on the left side, going to negative infinity. And it also falls towards negative infinity on the right side. So that is referred to as falls left, falls right. Then we have when our degree is odd. So if our degree is odd and positive, it looks like y equals x to the third. And we know that the graph of that looks something like this. And that is arrow down, arrow up. Or in the description, we can say that it falls on the left and it rises on the right. So we're just describing the action in words. And if it is odd degree, 3, 5, 7, but usually we use 3 for us to think about it's similar to, or if you forget, put it in your graphing calculator so you can remember what the end behavior looks like for these 4 types of functions. So it's odd degree negative, that would look like y equals negative x to the third power. And that one just flips around and looks like that. Now that is tail up, tail down, and on the left it rises left and it falls to the right. So it's important to understand all the various ways that in behavior can be described. And in behavior is one of those characteristics of polynomial functions that we can use in determining whether or not a graph is complete. When we look at it in the window of a graphing calculator or in a graphing utility like Desmos, are we seeing the whole graph? We can go to what we know about in behavior to answer that question.